Hey guys, you made it to the third and final video in this series, and on this one I want to show you more interesting examples and how the transformation happens step by step. Hey guys, and welcome back. This is Franck. If you have not subscribed already, go ahead and do so right now. Today I'm going to show you the step-by-step process on how to draft a function given its parent function. So the first function I have here is going to be f of x equals to 2 in parentheses x plus 1 squared plus 1. So as you can see this right here, the parent function or the basic function that this function came from is the x squared function. And so we're going to go through the x squared function and try to modify it through a set of transformation in order to obtain the graph of f of x. And so whenever you have to do this, it's important to know that you should always start with the inside, meaning the modification on the input, and then go out to get the modification on the output y. And also, remember from the previous note, we are going to do the opposite of what we see is being done to the input x. And so since our parent function here is x squared, starting with the input x, the first thing that's been done here is 1 is added to x, which means that the graph of our parent function is going to be shifted to the left by 1. Remember, we're doing the opposite here. And then that will be it for the input. And then since the entire function here is multiplied by 2, we're going to multiply our output by 2 as well. And finally, 1 is added to the entire function, which is going to correspond to a shift up by 1. And so let me draw an xy plane here so we can see how that reflects on the graph. And so the first thing that we need to do here is draw our parent function, the parabola. And as you know, our basic point for the parabola are going to be the point of coordinate negative 1, 1, and then 0, 0, and also 1, 1. So if you connect those 3 points, you're going to get the graph of our parent function. And so after that, we're going to transform each of those points in order to obtain new points for the graph of f of x. And so the first one here, the point negative 1, 1, the first thing we do here is we're going to shift it to the left by 1. So we're going to get the point negative 2, 1. Then the output y is going to be multiplied by 2, giving us the point negative 2, 2. And then finally, we're going to have a shift up by 1, giving us the point negative 2, 3. Next, we look at the point 0, 0. We're going to first shift it to the left, giving us the point negative 1, 0. Then we're going to multiply the output by 2. That's not going to change our point at all because the output is 0. And then we're going to have a shift up by 1, giving us the point of coordinate negative 1, 1. Finally, we look at the point 1, 1. We're going to be shifting it to the left by 1, giving us the point of coordinate 0, 1. Then we're going to multiply the output by 2, giving us the point of coordinate 0, 2. And finally, shift it up by 1, giving us the point of coordinates 0, 3. With these 3 new points, we can then connect them together, and that's going to give us the graph for the function f of x equals to 2, parentheses, x plus 1 squared plus 1. And so this is how you can get a graph of a function f of x if you know how to draft its parent function y equals x squared. Okay, so I have 3 other examples here so we can see this a little bit more and get more familiar with them. So the second example that I'm going to have is the graph g of x equals to 1/2 in square root. We're going to have 2x plus 2. And so first thing first here, our parent function or basic function is going to be the function y equals to the square root of x. And the modification that are being done to this, starting with the input x, if you look inside here underneath the root, remember that for the input, you do the opposite of what you see. And that also applies for the order of operation. So in this case, we're not going to do the multiplication and then do the addition. Instead, we're going to start with the addition and then go to the multiplication, reverse order of operation. And so the first thing we're going to take out from this is the plus 2. We are going to see that as a shift to the left by 2. And then the multiplication of the input here by 2 is going to be seen as a division of the input by 2. And that will be done for the input. Now looking at the outside here, the whole function is being multiplied by 1/2 or divided by 2, whichever way you want to look at it. So since that's done to the entire function, the output, whatever you see is what you do. So the final transformation here is going to be a division of the output by 2. And so how does that look like in the graph? First thing first, we need to draft our parent function. And as you remember from the previous notes, our 3 basic points here is going to be the point of coordinate 0, 0. Then you're going to have the point of coordinate 1, 1. And finally, the point of coordinate 4, 2, because the square root of 4 is 2. So connecting these will give us the graph of the parent function y equals square root of x. Next, let's go ahead and transform each of those basic points in order to obtain new points for the graph of g of x. Starting with 0, 0, we're going to shift it to the left by 2. Then we're going to divide the input by 2. bringing us to the point of coordinate negative 1, 0. And finally, we're going to divide the output by 2, which is not going to change our points because the output of our point is already just 0. Next, let's modify the point of coordinate 1, 1. We're going to reshift it to the left by 2, giving us the point of coordinate negative 1, 1. Then dividing the input by 2 will bring us to the point of coordinate negative 1/2, 1. Finally, dividing the output by 2 will give us the point of coordinate negative 1/2, 1/2. Next, we're going to modify the point 4, 2. Then moving that point 2 units to the left will give us the point of coordinate 2, 2. Then dividing the input by 2 will give us the point of coordinate 1, 2. And finally, dividing the output by 2 will give us the point of coordinate 1, 1. And so connecting those 3 points would give us the graph of the function g of x, and you will be done. Our next example here is the function h of x equals to negative 2 in absolute value x plus 3 plus 2. Again, our parent function here is going to be y equals to the absolute value of x. And then for the transformation, we're going to start with the input x. And you can see here that a 3 has been added to the input x, which means that the entire graph is going to be shifted to the left by 3 units. Then when we go outside of the absolute value, the function is multiplied by negative 2. So you can see this as a double transformation. First, a multiplication of the output by 2, and then a flip over the x-axis because of the negative. And then finally, a 2 is added to the whole function, which would cause the graph to shift up by 2 units. All right, so what does that look like graphically? First, we're going to draft the basic function, and we know the basic points here are going to be negative 1, 1, 0, 0, and 1, 1. Connecting this point with 2 straight lines will give us the shape for the absolute value function. Next, we're going to apply the transformation on each of those basic points in order to obtain a brand new point corresponding to the graph of the function h of x. Starting with the point of coordinate negative 1, 1, we're going to shift it to the left 3 units, then multiply the output by 2, then flipping it over the x-axis, and finally shift it up by 2. And that will give us the point of coordinate negative 4, 0. Next, let's take the point 0, 0. Shifting it to the left by 3 will give us the point of coordinate negative 3, 0. Then multiplying the output by 2 will not change our point. Flipping it over the x-axis would still not change our point. Then a shift up by 2 will give us the point of coordinate negative 3, 2. Okay, and the last point of coordinate 1, 1 will be shifted also to the left by 3. Then we can multiply the output by 2, flipping it over the x-axis, and then shifting it up by 2, which would give us the point of coordinate negative 2, 0. Finally, we can connect all these points, keeping in mind that we are doing an absolute value function. And so we're going to have the same shape here as the parent function. Okay, and my last example that I want to show you here, bonus one, is going to be k of x equals to negative, in parentheses, negative x plus 2 all the way cubed minus 1. And our parent function here obviously is going to be the function y equals to x cubed. And then we can go ahead and start transforming this function, starting with the input. And remember, we are doing the opposite of what we are seeing. Doing a reverse order of operation here, we're going to start with the addition by 2. So since we have an addition by 2 here, the graph is going to be shifted to the left by 2. Then the multiplication by negative 1 on the x here would flip the entire graph over the y-axis. As we get out of the parentheses, the entire graph is negated, and so that's going to be a flip over the x-axis. And finally, you have a negative 1 on the entire graph, which is going to be shifted down by 1. And so on the graph here, I'm going to start by graphing the parent function, and we know our basic points are going to be negative 1, negative 1, 0, 0, and 1, 1. Connecting these 3 points by keeping in mind the shape of our parent function, we're going to get a graph for x cubed. Next we need to do here is transforming each of those basic points in order to obtain new points for the graph of the function k of x. And so starting with the point of coordinate negative 1, negative 1, we're going to shift it to the left by 2, getting the point negative 3, negative 1. Then we're going to have a flip over the y-axis, giving us the point of coordinate 3, negative 1. A flip over the x-axis, giving us the point of coordinate 3, 1. And finally, we're going to have a shift down by 1, landing us at 3, 0. Next, let's take the point 0, 0, shift to the left by 2, and then flipping it over the y-axis will give us the point of coordinate 2, 0. Then a flip over the x-axis will not change our point at all. Finally, a shift down by 1 will give us the point of coordinate 2, -1. Finally, let's look at the point 1, 1 and see where that goes. A shift to the left by 2 will give us the point of coordinate -1, 1. Then a flip over the y-axis will get us back to our original point. A flip over the x-axis will get us to the point 1, -1. And a shift down by 1 would get us to the point of coordinate 1, -2. And finally, we can connect all of these points together, keeping in mind the shape of the parent function in order to obtain a new graph corresponding to the function k of x. And with that, we are done. If you like the way I break down the material, don't forget to give me a thumbs up, and I'll see you next time. Bye-bye.